Hi all. In this video I'm going to finish up the lecture notes from day 19. We started those in class previously and I'm going to finish those up here. And to do this we're going to look at the example, start with example 2. We did example 2 in class, but I want to go through that again for those of you who may want to see this again. Here we're asked to draw pictures of the normal curve to represent the following. The area representing values more than 1.3 standard deviations above the mean. So what we're going to do with this, let's first draw our normal curve. It looks vaguely like that. And in this, I want to have it look at where it's more than 1.3 standard deviations above the mean. So I'm going to put the 1.3 over here to the right, which represents the values above. And I want to have the shaded part be more than that. So this should be that part over here. In B, we want the area representing values less than 1.3 standard deviations above the mean. Again, we're going to start off by drawing our normal curve. We're going to draw quite a few normal curves. Again, the 1.3 is above the mean. 1.3 over here. This time I want the area representing values less than. Less than was the part I was supposed to be circling. All of this over here. Now, your pictures can be varying degrees of pretty, but you need to be able to notice some things about them. For one, you should be able to tell in mine for certain A is going to be less than 50%. It's going to be closer to 10% really, but you need to be able to tell at least that it's less than 10%. For B, you should certainly be able to tell that's going to represent more than 50% of the area under that curve. Alright. C, we're asked to find the area representing values less than 1.3 standard deviations below the mean. So again, draw our normal curve here. Here, the 1.3 standard deviations is below the mean. And we want to find the values less than that. So this should be the shaded part over here. In D, we're asked to find the area representing values between 1 standard deviation above the mean and 3 standard deviations above the mean. So again, we're going to start by drawing our normal curve. So our mean right there. Well, 1 standard deviation above mean would be right there. I know because I put a 1 there. And 3 standard deviations above should be right here. We're going to find the area between those. Alright, that looks pretty good. Let's move on to E. Here we're going to find the area more than 2 standard deviations above the mean or less than 1 standard deviation below the mean. So looking at this part right here, we want to have 2 standard deviations above. Put a 2 right there. That's supposed to be straight up and down. Let's try that again. Straight up and down. 2. Or less than 1 below. The 1's going to go over here. I'll put a little negative with that. I'll put a negative back there with the 1.32. Alright, so I want it below the negative 1 below or above 2 above. So that's the area I want there. And again, we should notice some things about this. If I looked at C right here, certainly less than 50%. In fact, again, it's about 10%. Here between 1 and 3, certainly less than 50%. Probably closer to about 20 or 30 at most. And here, again, it's a little hard to tell from the way that I draw these pictures, but it's going to be much less than 50%. Moving on to example 3, we're told the scores on a test are normally distributed with a mean of 80 and a standard deviation of 15. In A, we want to find the score that is 2 standard deviations below the mean. Well, on A there, well, if I start with 80, I can look at 80 minus 15. That'll be 1 standard deviation below. That's 65. Taking that 65 and subtracting off 15 again, that'll certainly give me 2 standard deviations below. 1 I subtract off, 2 I subtract off. Or I can start with 80 and subtract off 2 of them all at once. That should give me the same value of 50, which is the score that's 2 standard deviations below the mean. Question B, we're told 1 standard deviation, we're wanting to find the score that's 1 standard deviation above the mean. So I can take 80 plus 15, or 80 plus 15 times 1, and get 95. On C, we want to find 1/2 a standard deviation below the mean. Well, if I take that 80 minus, because it's below the mean, 1/2 of 15, that'll give me 72.5. And that's 1/2 a standard deviation below the mean. Moving on to example 4. Here we're told that not everyone pays the same price for the same model of a car. The mean price of a particular model of a new car is $21,500, and the standard deviation is $750. Alright. Use the empirical rule, that is the 68, 95, 99.7 rule, to find the percentage of buyers who paid the following amounts: between $20,000, $23,000, $19,250, and $21,500, more than $23,000, and the last problem should be less than $20,750. Now those particular numbers in this list are related to that mean and standard deviation, and let's see how. So let's kind of make a list over here. So I have the mean at 21,500. If I go up one standard deviation, that would be 22,250. So just adding the 750 to the 21,500 because that was the standard deviation. Up another 750, I'll get to 23,000. And one more 750, I would get to 23,750. So I'll see that 22,250 is one standard deviation above the mean. 23,000 is two standard deviations above the mean. 23,750 is three standard deviations above the mean. Going the other direction, that is below the mean, we'll see 20,750 is one standard deviation below. 20,000 is two standard deviations below, and 19,250 is three standard deviations below the mean. Now the empirical rule, that is this rule right here, the 68, 95, 99.7, deals with values that are within three standard deviations, 1, 2, or 3 standard deviations. So this is all of the possible values that rule could apply to for this example. Now on each of these, I'm going to draw a picture at this point. Alright, I noticed that I'm looking for values that are between 20,000 and 23,000. That is not what I want to see here. That is between 23,000 and 20,000. That was two standard deviations above or two standard deviations below. So I'm looking for the area right in here. Alright. Now again, the rule says 68% of data values should fall about within one standard deviation of the mean, 95 within two standard deviations, and 99.7 within three standard deviations. This was within two standard deviations on either side. The answer here is 95. End of story. And B, we want to find the amount between 19,250 and 21,500. Here, that 19,250 was three standard deviations below, and that 21,500 was the mean. So I'm looking for this area right here. Now this is not on both sides, it's just on the left hand side. If I had gone over the right hand side and included the three standard deviations above, I would have all of this part here. And all of that part, the black and chartreuse or whatever color that is, that would be 99.7% total. I only want the black part, the black shaded part, so I'm going to take that 99.7 and divide it by 2. I get 49.85. On C, I'm looking for the amount that's more than 23,000. 23,000 was over here on my list. It was two standard deviations above the mean. So I'm looking for this shaded area right here. And what I know with that is, we'll use green this time. I'm not using green evidently. Is that this full area right here was 95%. It's supposed to be 95%. Well, this black part's on the outside of that. So let's think about this. If I take the hole that's under the curve, 100% minus 95, I'm left with 5%. But that 5% includes this part over here along with this part over here. I only want half of that. I only want half of that. So the final answer to this question on part C should be 5 divided by 2, or 2.5%. The last question, we want to find the percent that are less than 20,750. 20,750 was one standard deviation below the mean. So I'm going to find this area right over here. So what I'm going to do is take note of the fact that if I had been asked this amount right here, it's 68%. Right in there, if I take that 100 minus 68, there's 32 on the sides outside of that. I again only want half of that here, and that should be 16%.